Hello, I'm Mr. Anderson. This video is on Chapter 1, the fundamentals. In this video, I'm going to go over some of the biggest topics in Chapter 1, but it would be important for you to go through Chapter 1 on your own, as I won't be able to fit everything in Chapter 1 into this video. All right, first up, interval notation. This may or may not be something you've seen before, but it's not hard. Interval notation is just a way of showing an interval or a range of numbers very quickly and easily. You can also do it with an inequality, but interval notation tends to be faster and easier. So for instance, the inequality x is between 4 and 10, non-inclusive, meaning x can't be 4 or 10, would look like this in interval notation. If, on the other hand, I had an inclusive inequality, like this, x is between 25 and 38, including 25 and 38, it looks like this in interval notation. Right? The advantages of interval notation is it can be a lot quicker to write. The only thing to really pay attention to is noticing the difference between a bracket and a parentheses. In interval notation, a bracket is used when x can be equal to that end value. A parentheses is used when it can't be. So, a couple examples. Here's an interval notation right there. You might want to pause the video and make sure you can rewrite that as an inequality to make sure you understand this if you haven't seen it before. All right. As an inequality, this would look like this. Negative 2 is less than x, not less than or equal to, because that's a parentheses. And x is less than or equal to 9, because that bracket means that I can reach that endpoint. All right, this means x can be anywhere from 5 all the way up to infinity. Yes, I can write this like this. 5 is less than x, which is less than infinity. That's a fine way to write an inequality. However, you'd typically see that inequality written like this. X is greater than 5. All right, moving on. There are some formulas you should have memorized. Namely, these four. These definitely measure different things. You use them at different times, but these are all formulas you should be familiar with. Again, you may want to pause the video and kind of quickly go over those and make sure you already have them memorized. If there are any you don't have memorized, you're going to want to make sure you write them down and spend a little time memorizing them so you don't have to continually look them up when they are required. Quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Quadratic formula, of course, is what we use when we're trying to find the roots of a quadratic equation. Distance formula. Distance formula is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You might recall that this distance formula comes straight from the Pythagorean theorem. I'm not going to talk about that now, but you can easily Google it if you want a refresher on that. Midpoint formula. Midpoint formula, any midpoint, let's call it xm for the midpoint and ym for the midpoint. That'll be taking the average value of your x values, so x1 plus x2 all over 2, and the average value of your y values, so y1 plus y2 over 2. And very last, the slope formula. Oftentimes we use m for slope, but slope formula looks like this. You take your y values on top and you subtract them, x values on bottom and subtract them. That, of course, you should have memorized. It's rise over run. Subtracting the y values is how you get rise. Subtracting the x values is how you get run. All right. Moving on. Intercepts. If I was trying to find the x and y intercepts of that equation, that is a parabola. I happen to know it looks something like this. So let's start with a y-intercept. You just plug in the 0, right? You'd say 2 times 0 squared minus 3 times 0 plus 1, and you'd figure that out. The reason why that is the y-intercept's going to be right there. It's going to be some point that goes 0 for the x, has 0 for the x, and something for the y. So if you know the x is 0, you plug 0 in. You end up with a y-intercept of 1. To find the x-intercept, same idea, but the x-intercepts, and it looks like there's going to be 2 of them. X-intercepts in this case is going to be some number comma 0, where 0 is your y value. And so in this case, you plug 0 in for your y and you try to figure out what your x values can be. I would have 0 equals 2x squared minus 3x plus 1. This thing here, I need to either factor it or use the quadratic formula. When you're doing that, always do the easiest method first if it's possible. Quadratic formula is great. I love it, but factoring is just straight up faster. So if it does factor, that's always what I check first. This one does factor, right? Factoring was a lot faster than the quadratic formula. Let's factor it. I've got something times something else is equal to 0, so one of those things has to be 0. Either 2x minus 1 equals 0, which would make x equal to 1/2, or x minus 1 equals 0, which means x equals 1. So those are my two intercepts. All right, let's move on. Linear equations. You should know what the slope-intercept form of a line looks like. You should know what the point-slope form of a line looks like. These are the two big ones because these are the two that are really useful. So slope-intercept form, hopefully you already know. That's y equals mx plus b. Point-slope form of an equation, that's y minus y1 equals slope m times x minus x1. All right. Parallel versus perpendicular. Hopefully you already know this as well. Parallel lines have the same slope. Perpendicular lines, I'm going to use a symbol for perpendicular. Perpendicular lines have slopes that are opposite reciprocals. Opposite meaning opposite sign, so one's positive, one's negative. Reciprocal meaning the fraction is flipped. If you need an example, let's say we had one slope was 3/4. The opposite reciprocal slope would be -4/3. Should be something you're aware of. If not, study up on that. All right, we are almost done with this section. Quick example, write an equation of a line that goes through 1, 2 and is parallel to 3x plus 5y equals 17. All right, so first off, you're going to want to think what form you're going to want to use. In this case, does slope-intercept make more sense, or does point-slope make more sense? And when you look at that, I would definitely say point-slope form makes more sense, because they gave me a point, not an intercept. The point I was given, 1, 2. I'm halfway there. To find slope, I use the fact that I know I'm parallel to this equation, so I need to figure out the slope of that equation. That is not written in either of my forms right now, so the slope is kind of difficult to see, but we could pretty easily rewrite it, right? I could write 5y equals 17 minus 3x, which means y would be 17/5 minus 3/5 x. That is now in slope-intercept form. Of course, I wrote my slope here first. If you prefer the x, it doesn't matter. You could write this as -3/5 x plus 17/5. Doesn't matter. What is important is I can see my slope now. Slope of that line is -3/5. Since I am parallel to that line, the slope of the line I'm looking for is also going to have a slope of -3/5. Now that I have a point and a slope, I can write the equation of this line. Because of those two things, I'm going to write it as y minus my y coordinate, 2, equals my slope, -3/5, times x minus my x coordinate, 1. All right. Tests for symmetry, we are almost done with this first video. All right. Symmetric about the y-axis. Many of you guys might have just memorized something last year probably about replacing x with -x, and if you end up with the same equivalent equation, you're symmetric about the y-axis. Real quick example, you might have seen something like this. Let's say we've got y equals x squared, and you replaced x with -x, then you get y equals -x squared. But that simplifies to y equals x squared, and you'll notice my original and my new one after I replaced it, they are equivalent. If that happens, you're symmetric about the y-axis. Why that makes sense is kind of important, so we should talk about that a little bit. I'm just going to make up some random equation. Let's say, or not equation, I'm going to make a graph. Let's say my graph looks, I don't know, like this. All right, if I was symmetric about the y-axis, here's my y-axis, that means any point on the graph on this right-hand side should show up reflected over the y-axis on the left-hand side. So let's say this is a point A comma B. If that was A comma B, that should show up on the left-hand side of the graph right about here at the same exact height, but with an opposite value of the x. Instead of A comma B, that would be negative A comma B. You'll notice that the x values are the same thing, but a negative version, right? And the y values end up being the same. So when you're symmetric about the y-axis, basically it's saying if you plug in a negative version of your x, right, a negative a instead of an a, you should get out the same value of y. Here I plugged in a negative x, and after I simplified, I found out that it was still equal to the same y. It was the same equation, right? Symmetric about the x-axis is the exact same thing, except replacing y with negative y yields an equivalent equation. We could check, let's just check the same one. We could check if y equals x squared was symmetric about the x-axis. Now we already know it's not, right? Like if I graph it, we know it looks like that. That is not showing up down here, so it's not symmetric about the x-axis, right? There's no line of symmetry right there, where the top and the bottom are the same. So I know it shouldn't yield an equivalent expression, but I could check to find out. If I replace y with negative y, I'll have negative y equals x squared. If I solve for y, I get y equals negative x squared. Those two are not the same. So y equals x squared is not symmetric about the x-axis. Is symmetric about the y because they are the same, not symmetric about the x because they're not the same. All right, very last one, symmetric about the origin. That happens when replacing both the x and the y with negative x and negative y yields an equivalent expression. Again, we've done it. We've checked y equals x squared with both of them. We might as well check it here again. Y equals x squared. Before we check it, we should just think about that. Does that look symmetric about the origin? Hopefully not. Symmetric about the origin means if I had here's the origin. So if I had something that went like this on the one hand side, reflective over the origin would be reflected back the other way. It'd be down here. If it's reflective over the origin, any point that shows up here, let's just pretend that's 4, 5, should show up down here at negative 4, negative 5. Notice the same x and y's, but negative. Now that does not happen with y equals x squared. So this should not work out. But that's fine. You know what? I'm going to change this. Let's make this y equals x cubed. Because it does happen with y equals x cubed. Right? And y equals x cubed, if I have a point here, let's call that 2, 8. I do have one over here, negative 2, negative 8. So this one should work out. Let's find out and just make sure. Y equals x cubed, if I place y with negative y, I'll have negative y, equals if I replace x with negative x, I'll have negative x cubed. Well, that makes negative y equal to a negative times a negative times a negative 3 times. It's still a negative. And then multiply both sides by negative 1, y equals x cubed. These are the same. So that one is symmetric about the origin. All right. Last thing for this video is the equation of a circle. The equation for a circle with center h, k and radius r, we should know what that looks like. It's x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. That also comes from the Pythagorean theorem, uniquely enough. I don't have time again to talk about it, but it wouldn't be a bad idea to check it out for yourself. Google it, you can see why the equation of a circle is what it is. Quick example about it, write an equation for the circle centered at 3, 0 with a radius of 5. All right, well that'd be x minus an x coordinate of 3 at the center, squared, plus y minus the y coordinate of 0, so just y squared, equals a radius squared. Radius was 5, so equals 5 squared, which is 25. There is the equation of my circle. There was more to this thing. It asked me to then test my equation for symmetry about the x-axis, the y-axis, and the origin. I think for this video I'm going to scratch that one out because I think we talked about it enough in the previous section. But I am going to end this video here, and I will see you in the next one.